mistake thing. This is good. I want to make sure it's not going to get blown off course by perhaps some loose metaphysics. Not necessary. Yeah.
So I mean, the reductionism has certainly had plays a big role in our thinking. There's no doubt about that. It has from the very beginning, you know. And yeah, we've had lots of toing and froing, haven't we, in the team about what we mean by reduction, the different versions of reduction. You know, really, is this argument sufficiently anti-reductionist? Have you made your point, or is it all methodological? Is it metaphysical? And you know, we have these.
That's one of the things that you can get to the various senses of reductionism on offer, and ultimately, I guess if I were to put myself in one of these positions, it's a very, very moderate anti-reductionism. I don't want to give up on certain features of standard reductionism because I think they're crucial to keeping a unified natural order and making sure that we've got relations between the sciences that aren't just haphazard. So I've got certain metaphysical reasons for wanting there to be let's not throw the whole thing out, but let's be careful about expecting biology just to be more physics. I don't really think that's likely, but let's not get too.
I think that there's two things that I think are the way we've thought about it. One is that if one's arguing against reductionism, it shouldn't be purely a negative argument. In other words, the anti-reductionist position should do work, should take you somewhere rather than just stop you going somewhere. Yeah. And the other is that it's well tested when we have the discussions, the biological discussions, because we can say something based on the conceptual sort of position, and then the question is, well, is John going to say, well, actually, for a working biologist, that doesn't run, and that would be a really important point. I don't think it's actually happened so far, but it would be a really important point if we said, well, our conceptual position is this, and the biologist says, well, that simply isn't recognisable in what we're doing.
Well, at the end of the talk, I'm going to give a list of theses that I use to characterize the sort of moderate anti-reductionism. And so it would be interesting for me to hear whether there's something, if this is just flat out not fitting with biology, because it's in part designed to do that. As far as I want it to be consistent with biology as we know it, and wouldn't want to be, in the battle between the metaphysics and the natural sciences, and biology in particular, I would be hesitant to put the metaphysics before the biology. So, yeah, let's just put that out there. I mean, enough of a naturalist. Want to make sure that I'm not saying anything. Non-factual. That's a basic requirement of any metaphysics, any responsible metaphysics. Right. We happy if I just continue?
Yeah.
Seated? Just to see my.
You could just click on, I think on the screen there, you can see the arrow.
The page down. Does that work?
It did. Yeah.
Yeah, okay. For me, there were three main themes, philosophical themes coming out of mistake making, and no surprise, really, they're the issues that you were identifying in the limitation section. We've got notions of functional teleology in there, concerns about the underdetermination of theory by data, been haunting us since Duhem, and then there was the commitment to, well, saying, look, this is an anti-reductionist paper, this is an anti-reductionist proposal, but we haven't argued for it here, and so clearly people are going to, it's going to be open to people to challenge us on particularly that front, as well as the other fronts. Now, David asked me to focus primarily on reductionism, and that is going to be what I do.
Sorry, do people mind if I close the window? Can you leave that open? I'm getting cold from
That
the
noise or temperature?
temperature. I'm getting like the draft in the back. Sorry.
So I'm going to focus on the third, but just a quick aside, one of the reasons why I ended up starting to change direction, and it wasn't just going to be about reductionism, is that it looked as though those three topics can't really be separated entirely. There are relationships between the two of them. When you start to unpick one of them, there's implications elsewhere. And because I take the reductionist agenda, I mean, ultimately I think it's about trying to preserve the unity of the sciences. And it's not just about physicists wanting to rule the world and saying we're the most important science. I don't think that's really the main motivation we're doing. It's trying to make sure that we've got a relationship between the various natural sciences that's systematic and organized. And reductionism is one of the ways of doing that. And so, for me, there's a prima facie plausibility to doing that. As a metaphysician, I am hoping that we'll be able to say that reality is a coherent system. So this is just one way in which reality could turn out to be a coherent system, having reduction support. But the picture of what the mature sciences look like, particularly in the 20th century, have got extra metaphysical baggage that goes along with them. Really haven't had much room for functional teleological concepts. That's being nice about it. They've also been haunted by the other determination thesis, and as far as I can tell, they haven't really come up with an adequate solution to that. And they recognize it. I still think Duane's approach to it is probably best, but nobody seems to talk about it as much these days, which is, for me, it's a real shame.
Can we jump in, or yeah. What is Duane's determination of?
It's the idea that for any given set of observational reports, data, any number of theories could be compatible with it. And the reason this was picked up by Quine in the middle of the 20th century was it became clear that Popperian falsificationism was not going to be, it's not really going to work, because the relationship between data and theory wasn't as tight as everybody had been hoping for, essentially. And so every time you have a theory that fits the data, well, that's great, but there's other theories that could be fitting it as well. And if your theory doesn't fit the data, you can get around it by bringing in all sorts of extra hypothetical assumptions that have been thrown out and whatnot. So you can save any theory as well, regardless of what the data is. And in the limitations section, you talk about, you take this even further and say, well, there's theories that you haven't even thought of yet, which could very well fit all the data as well as any theory that you've got at the moment, in which case we're back to the Popperian problem of how do you demarcate science from non-science. Before it was supposed to be, there's some kind of discipline that's put on us by the empirical world, and now it's not clear that discipline is actually there. If you rely purely on empirical information and logic, it looks as though the constraints are not strict enough to be able to give us rational grounds for choosing one theory over another.
I'm not sure we want to discuss this really. As a scientist, I go like, not a problem, and I don't care pretty much, because that's not what we're trying to do. I mean, for a long time, this has not been anymore what we're trying to do. Truth with a big T type of thing. I want to predict this as efficiently as possible in as many situations as possible. Your theory, it's a good theory. It stops doing it, it's a bad theory. I have two theories we have situations where you can show that two theories are completely equivalent, but completely different.
Yeah.
And they make the same predictions. Nobody can decide which one is which is true. It doesn't matter as long as you do get the same. So all I'm trying to say is, from a practitioner's point of view, I don't think this is a big one.
Yeah, I think, see, and this is, we're going to get to this later when we get to Dupre, because if you go anti-realist about scientific theory, then yeah. If you don't think that your scientific theory is necessarily going to be telling you anything about the way the world actually is in itself.
I didn't say that. I didn't say that at all.
Well,
I just didn't say, when I speak my theory, this is the truth. I'm saying it still delivers to me, for example, a prediction, right? That is real. I mean, if it tells me this is going to happen, and it's going to happen, that is something very real about the world, but that doesn't necessarily imply, like the success is real, if that makes sense, but not the act of getting to I don't know what that is. And I think almost all scientists would go that way these days. Your theory is not, it's very hard to constantly think your theory could be wrong. That's not what you do in practice. But in reality, what you're trying to do is, can I describe the data that I have? Yeah. Can I make reasonable suggestions about what I should be seeing in other circumstances? Yeah. Can I generalize too many things? That's the questions that you actually ask. Yeah. And as long as that's okay and that's some reality, why would I be concerned? Is what I'm asking. What else do you want of this theory? I'm just trying to explain what we actually do, right? I'm sure almost all my colleagues, you speak for yourself, but it's more or less what you need. You're concerned about the practical aspect, and reality is in what I can predict, see, explain, but not.
I guess it's the concern might be more of a concern for the philosopher of science than for the metaphysician who wants to take the scientific results as being informative about the way the world is, and we're trying to come up with a coherent theory about it.
It's not entirely not that, right? That's an interesting thing. It's not nothing about the world. It says a lot about the world. It's just your words about the world are not, again, if I can tell you, you light this up, it will explode. If I throw this out the window, it will land in 2.1 seconds on the ground. These are real things.
Yeah.
They're undeniably factual, predictive, anything you want. That doesn't necessarily mean that I believe that Einstein's general relativity, or for this maybe Newton, is the theory. There's people that say there is no freaking space-time now. That is a complete illusion. So
I think that's the worry. That's where the metaphysician starts getting worried. We were hoping it wasn't going to be like that. We were hoping that the sciences were going to be able to come up with, well, some of us anyway, in the early 20th century, we were hoping we could just hand metaphysics over to the sciences, and you were just going to tell us the way the world is. And it hasn't turned out like that. And for the philosophers, and Dan was both a practicing physicist as well as a philosopher, this was the worry for him, that we have to recognize that any number of theories that are incompatible could both adequately fit the empirical data. If you want, then you're
what do you mean by incompatible?
They say contradictory things about the world at the theoretical level, not necessarily at the experimental level.
Yeah, they're logically inconsistent. So heliocentric and geocentric, right? The one the philosophers of science use all the time in undergraduate lectures, the Galileo versus Copernicus, right? You had two theories which strictly are logically inconsistent. One says the Earth goes around the Sun, the other says the Sun goes around the Earth. They can't both be true. And yet, at the time, they were empirically equivalent.
Yeah, well.
Some people would say they're still empirically equivalent, but the point is at the time they were empirically equivalent. Well, and you had to make these kind of very specialized observations of star behavior, starlight.
I think there is like a difference between truth and, I don't know how to say that. Practice seems like a weird way to say this, but even at the time when the heliocentrism became strong, geocentrism was actually better fit to the data.
Yeah.
So the reason it got adopted, heliocentrism, is because it was simpler, easier to do in your head. It was terrible to do these freaking epicycles. Nobody really knew what. It worked, but it seemed like too hard to be true, if that makes sense. Yeah. So there is these sort of things going on, and often enough, but not always, often enough they prove true in the long run. True in the sense of there is now things where literally nowadays you can just literally go to space and look. So you can find empirical data now that says there is no geocentrism. It is also not heliocentrism, but no, that's closer to the truth. So I'm just saying there's a lot of things going on that are not as simple as, you know, like these are equivalent. Very few things are equivalent in a practitioner's mind. Like when I tell you Bohm's theory of quantum mechanics is the same as the standard one, then you can ask immediately the question, why is nobody using Bohm? And the reason is because some of the concepts that I use there are alien and they're kind of like weird in your head, and you go like that's terrible math too to do it. So since I have two things to do, they give the same results. I take the one that's nicer. So people might say this is true, but it's not true in the. I mean, it's not a proof. It's nothing. It's just a convenience almost. It's a thing.
In my ears, that sounds like instrumentalism.
Yeah. Well, I don't know. Yes.
And maybe for practicing sciences, that's really the way you should go. Van Brassen certainly thought as much. You know, make sure your theory is empirically adequate. Yeah, but that means it's problematic whether we take a scientific theory as actually telling us much about the world, as opposed to it's easy to work with. I can make good predictions.
Whenever you say much about the world, it goes like, what do you mean? Because it says a lot about the world. Maybe not what you want to hear about the world. I mean, you do scientific theories because they tell you lots of. You don't do them for fun. It's not math, right? You're not. it's not.
I think it's often more about fundamental ontology, though. I mean, because when you think about different interpretations of quantum mechanics, what they say, like what the Bohmian says versus what like the GRW says, are just so radically distinct about what the world is that like even if they're the same predictive-wise, like you get the same input-outputs, like what the actual structure of space and time are so radically different that it worries, I think, philosophers when we think like, well, what is the world, what is this telling us about the world? And you're saying, well, it's telling us about, you know, we can still calculate the wave function, it's fine, that's deterministic, I'll get some results, they both do the same thing. We're worried about, yeah, but what is the world like at bottom?
Yeah, but the point sort of is, for the practitioners, in this case, in this very particular case, the equivalence is strictly mathematical. It's not even just that they're as good as describing. You literally can go from one to the other mathematically, which means they are literally equivalent in a theoretician's mind, right? So you cannot, there is no way to cut this. What you can possibly do is to find something that neither of them describes, which is less of a stretch for one than for the other. You know what I mean? It's like you can say, here's something new, and I can extend this there, but I cannot extend that there, then I would favor this one. But there is nothing, it is provable that there is nothing you can do, ever, to distinguish the standard quantum mechanics from Bohm because they're mathematically equivalent. That's the same as saying, originally, you know, like there was Heisenberg and Schrödinger, and they had two versions of quantum mechanics. And the one was doing matrices, and the other was not. And the other one was differential equations. And then at some point somebody said, well, actually, you can do this and this, and then you show that the math is equivalent. At which point everybody said, well, it's the same theory then. The same thing is true for the Bohm stuff, except that, as you correctly point out, in terms of like conceptual, one of them seems like, okay, I kind of get this. The other is like, okay, what, nonlinear interactions, and it's all deterministic, but so it's weird and it doesn't fit into our general thinking, so that's why it's neglected. But mathematically, you cannot. And once it's mathematically the same, you know, there's literally nothing you can do. There's no prediction you can possibly make that would distinguish them.
I mean, maybe this is too far away from topic, but like, are you saying that you can mathematically transform pilot waves, as it were, into density matrices?
Yes, they are literally mathematically equivalent.
Okay.
Some philosophers would then argue if that's true, then they just really have the same theory.
Yeah, well, exactly. That's
but then that's not a problem of underinterpretation anymore.
You listen to what they're saying, like, that's what he was saying. They're radically different in what they're saying about the world. One is saying that's a probabilistic wave function.
Well, like you said, conceptually, right? I mean, if you're talking about what one's picture of the world while looking at them, you might think this is a radically different description of the world. But they're also, I mean, it's not an unphilosophical thing to say, well, they transform into one another, so it turns out they're the same thing.
But say you met a metaphysician who was interested in space and time. What would you advise them on the basis of?
Advise them what?
Don't do it. Don't do that.
No, advise them of what? What's your question?
if you've got a scientist who's a metaphysician who's interested in basing their metaphysical accountability on the sciences, and you have two theories that are like this, what would you advise them to do? Just don't worry about the conceptual stuff that goes with it, and just go with
I would say whatever you want to say is real about the world cannot possibly depend on their conceptual distinction, because they are both equivalent for all we know. Like, it's always like, science is always like, and who knows, maybe tomorrow it's all wrong type of thing, but that's a different issue again. I mean, if you trust what is currently on the table, then the only thing we can say is, pick your poison. I don't know. There is good reasons why people don't like Bohm, right? For example, this entire extension towards general relativistic physics is kind of like really odd with Bohm's mechanics, but it's kind of more intuitive with quantum mechanics, which is why you have quantum field theory. And so there is already this kind of extension where you say, well, one thing was able to grow, the other was not. So de facto we can distinguish, but not on the grounds of their own domain, on the grounds of extendability, of applicability, how you get further, which you can. But I don't know I really don't know what to say to that question. It's like, I cannot give you a distinction if there's no distinction. There is nothing I can do. I can only say, I can say this, I can also say this, and anything I can possibly do will be the same.
So philosophers would just be mistaken in saying that there is a real distinction between these two accounts of the real world. They're just kind of confused, and they're saying the same things in different...
Well, possibly you can find the one ground behind all of them. That's possible. It's just not done. I mean, I can't exclude that. There might be like a way of kind of like thinking higher than both and having a view that kind of encompasses, like that makes it obvious why you're kind of looking at the two sides of a coin, if that makes sense. That could be the situation. You're kind of looking at one side of a coin, you look at others and saying these two sides are terribly different, but actually if you kind of manage to go up somehow and see, well, that's just a coin, that's possible, but I cannot tell you that is true because I cannot do it. So, I mean...
Yeah, I mean, you make it sound like, and you talk about this in an instrumentalist way, you make it sound like there are these, clean predictions and, then they make the same predictions, then I don't really care which one you use, But I don't think predictions work like that, at least in all the sciences. It might work for things where, I predict that I'm going to see this particular thing under a microscope. If you've got two theories and one says, I'm sure if John's faced with two theories about blood clotting and one of them says you're going to see this under the microscope and the other one says you're not going to see this under the microscope in exactly the same conditions, and you do see this under the microscope, then you're going to go for that theory. The other one theory doesn't look like it's doing its job.
But that's not...
But physics, predictions about what? Predictions about readings on very complicated measuring devices, like, Large Hadron Colliders that are so theory-laden with conceptual... Well, these are not just... predictions.
No, I totally agree. I mean, I'm totally agreeing with all of that. These are not clean and pure, but this particular example is...
Maybe that example. We don't get hung up on one particular example.
Yeah, okay, but I mean, I'm totally agree that there's a lot of determination of. I mean, in some sense, you see what you see, and there is parts of sciences which are very like actually biology is often quite experimentalist driven in the sense of. The experimentalists, they are not theory-free either, but they have theories in narrative, what I would call narrative theories in their heads. They have an idea of how things work, not necessarily in a physicist way of writing a formula, but you have an idea like this goes with this typically, and now I should probably look at this, whether it fits into this puzzle. So you have like a jigsaw type of puzzle of how things stick together and do. So you do have theory, even if it's not necessarily spoken. In the same, or mathematized is maybe the right word. So
it's sort of almost simpler. Yeah. It's sort of like drawing the maths in cartoon form. You don't need to actually worry about the details in quite so much depth.
I'm not sure that is true. It's a lot of depth that you have in your file.
Well, maybe it's a different sort of depth, but I guess it's interesting you use the word prediction as well, because actually the way maybe it's just me, but the way I approach experimental work is always by a hypothesis, it's always a question. So in my head I might think I know how something works, but in order to establish that or to distinguish between two possibilities, I'll design an experiment that hopefully will enable me to say that one's probably right and that one's probably not right.
Sure.
So I guess it's the same thing, that's just flipped.
Yeah, I mean, I'm not at all against that. And I mean, that I'm not trying to say that this is like special in, I mean, I totally agree with you also that there's a lot of, like, LHC is a wonderful example of where it's extremely hard to distinguish between theory and experiment because it is so intertwined. You're basically throwing away 99% of all data based on theory before you say, now I'm looking at the 1% left to make to call that experiment, right? You know that, but you know that I'm not saying any of that. All of that is fine. I'm just saying there is this idea of the idea of that the total truth about the world is kind of driven out of physics like 100 years ago. It's gone.
Total truth?
Yeah, like a theory is. I mean, I don't know. The simplest expression of this is the Copenhagen prescription: shut up and calculate. Right? That is literally what physics now is, and it's not by free choice. It's by force. Right? We were forced to admit that we cannot do it anymore. It's not possible anymore to say this is it. Every time we did, we fell on our face, and harder until quantum mechanics pretty much came around and killed it. Right? We cannot anymore say this is it. It's now just okay. I have these things that I can work between, and I think it's just part of. I think everything is like that. To be quite honest, it's just physics is kind of furthest ahead in some sense, and this got hit hardest by certain things. But
yeah, maybe we should get back to we could talk about determination.
I didn't really want to get into.
I'd be interested to know if the biology is quite as instrumental as the physics. I mean, my guess is that it's not. And
the implications for health and disease and treatment, and you know, you want to make sure that your terms are referring to actual things rather than just like a prediction.
Yeah, exactly. So.
Yeah, but I mean, again, you keep saying things like actual things. You know, I mean,
actual
physics is about actual things.
Platelets are real. It's not just theoretical.
So are electrons, and you know, I mean, there's nothing in what I said that has anything to do with not being actual. That's the problem. You're trying to go anyway. Let's continue with this.
Yeah, let's see you back to
really amazing. This is really wow. All right. This has been good for me because I thought that was kind of standard. And I'm just thinking, I mean, why do we insist on governments, you know, following the science? You know, we follow the science on this, and now it sounds like, wow, which science? I'm not.
Well, you keep on putting the wrong. I don't know. Maybe I'm expressing myself really badly, but you know, like there's nothing better than what you can get here. What you're looking for something better, and that's the point. If there was something better, we would definitely want to get it.
I think that's the scary thing because, you know, I'm hoping to get more out of the sciences than what you are suggesting is on offer. And you're saying, look, that's just the way the world is. You're going to have to, you know, deal with it.
Well, I mean, maybe you can, but not from science. I mean, I'm not even saying that it is impossible to get to a higher truth. Maybe you can. I'm just saying, if you literally ask the empirical scientists, all it in the end can do is collect data, have like theories, do predictions, do explanations, see if it fits, make bigger. It's a kind of like almost a mechanistic thing. Like I mean, it requires cleverness and clever people. It's not mechanistic in that sense. You can't be dumb to do this. But in some sense, what you're doing is almost like a prescriptive thing. You have things, you make them into bigger structures. And in the end, what the truth about that is in exactly these structures. They are what they are, but they're not beyond themselves. And if you're looking for beyond that into then, you know.
Yeah, because I want to know what the world is like. I don't really know what the latest, you know, most comfortable theory for physicists to use.
And we should talk more, maybe not now, but about the transformation between two theories being functionally equivalent and what that implication has on ontology, because I mean, it is a fundamental question when you think about like Noah's laws. It's very interesting thinking about like, conservation and stuff.
I mean, the other thing which was maybe not so clear, that at least in physics, I think the reason I'm keeping talking about physics is not because it's so different from biology, frankly, it's because theory is so developed. I think that's the biggest difference. Theory is so strong in physics already, whereas in biology, with all due respect, it's kind of like a bit weak in the making. Let's see.
I wonder whether some of that's due to scale. So I realise that I guess a lot of the science, a lot of the techniques we use as biologists and a lot of techniques you might use as a physicist are enabling us to try and test ideas out when you can't actually see the things that you're testing. They're too small or they're too indetectable, or you need to develop special machinery in order to, in the case of the physics, and it's similar in the case of the biology. So I guess in many respects the concepts are similar, but I see biology as being complex at slightly different levels, so at the point where you potentially have a number of different explanations for the same outcome, whereas the physics you might expect it's how it is. I mean, you might disagree.
No, I was just about to say, like, physicists constantly operate with this idea that the theory is not really true. We're still using it. Like I know that Newton's physics is not right.
Yeah.
It's completely wrong.
Yeah.
In all aspects, like provably wrong. Constantly use it anyway for almost everything, and I know exactly what my parameter, or not exactly, but I know roughly in which realm I can do it.
Yeah.
Then you go special relativity, and you go like, yeah, I can do this, but it's also wrong. Then you go general relativity, it's also wrong. Then you go general relativity and go to a black hole, and you say it's also wrong. I don't know what to replace it with.
We need a separate seminar on scientific progress.
I'm just saying,
come back next week and give us a seminar.
but I'm just saying, physicists constantly have this hierarchy of truth where they jump from one thing to the next and go like, yeah, I know this is wrong here, let's do this.
Yeah, but like the strive in that, like why was it interesting that Newton's laws were like able to be approximated from relativity?
Yeah.
The reason why it's interesting is because you found a higher truth, as it were, right? I think part of the philosophers, maybe the tension here in the philosophy is to think, well, yeah, but we want to get to the end goal of that, where we get the ultimate thing from which.
Me too.
Well, yeah.
Visually, that's what physicists would love.
Well, yeah,
So maybe not ego, but
Right.
No, totally. I mean,
love
if it is there, I would love to hear about it, but
Anyway, let's get back onto our main topic. Otherwise, we're going to be having a whole seminar on philosophy of science. You've opened up a can of worms there, Steve.
Yeah, fascinating. Well, well, I think whether that illustrates my point there or not, I don't know. But essentially, you had the three issues: the functional concepts, and underdetermination, and you had reductionism, and they're related. So if you start unpicking one, you're likely to unpick others. Now, just got some stuff here. This is meant just as a brief aside, because I've been looking at the philosophy of economics, which going the other way, right? We've been going down physics, and I've been worried about philosophy of economics, particularly since the crash of 2008. What's been most interesting about this from a philosophical point of view is that the economists themselves have started recognizing maybe we don't have our own discipline under control. They've largely been going with this paper from about, I think it's about 51, that economics, and Milton Friedman, which is essentially a positivistic approach to things. But now they're looking for completely new, at least some of them anyway, are looking for new ways of organizing research in economics. And I've been looking at one of these alternatives that I've managed to kind of come across with some people who aren't part of the mainstream of economics. It's one of the reasons for going there. They haven't been hit by the positivistic backlash from 2008. And it's based on the idea that of part-whole relations, and then relations between wholes, and which are themselves parts of something much broader. And the reason I was interested in that is because it doesn't have reductionistic ambitions. It's just not even interested in that at all, raising the questions about that. There's no issues for them about functional concepts. They're perfectly happy with function, and because there's agency involved, you can even get the old-fashioned acting for a purpose. They're perfectly happy with all of this, and to me anyway, without knowing all that much about systems biology, it made it look to me as though there's an analogy between the way that these guys are going about thinking about economic phenomena and systems biology. part wholes, but then wholes, and then the systematic relationships between the two, with the relationships that are happening between the wholes that are part of systems being as important, if not more important, than the initial constitutive part-whole relationships. And just, if you're interested in economics, you're interested in depression, just throwing this up here, Fisher had this theory, had this account in the 30s, and it's now coming back into fashion with a lot of economists who are trying to explain what the hell happened in 2008, and Fisher's theory is being resurrected now. The interesting thing from a philosophical point of view is not so much the claims, but how the claims are supposed to be related. All of these claims are supposed to be about some part of the whole economic system, and once you understand what the parts do within the system, you can deduce. That's his work, and you don't really need to be relying too much on the way of experimental hypothesis testing, because you can see the nature of these wholes dictates that a move of one kind is going to necessitate a move of the other kind, just because they're part of one system. And I thought that's quite interesting as an illustration of how your picture of what a mature science will look like will have an influence, an impact on what you say about reduction, function, and lots of other matters, because it's neutral vis-a-vis reductionism. Like I said, it's comfortable with functional concepts. And like I said, there's an analogy here with systems biology, which I thought was more than just passing. So that was one of the things I was looking to get today in terms of feedback. I know there are systems biologist people here. Whether I'm going to be saying anything that is wildly out of step with how systems biologists might think of what they're doing at a very abstract level, a high level.
Thank you, the system biologist in this case.
So, yeah, I mean, I can see the analogy works quite well in the idea of having a complex system of sort of interrelatedness between different components. I think systems biologists quite often deal with huge amounts of data and don't necessarily understand why it performs in the way it does. So there's a sort of slightly more, I guess, I almost hesitate using this word in this context, but sort of reductionist approach to experiments where you might have a very simple question, you test it out, you see what happens, it enables you to draw some conclusions from that experiment, and that might seed another question that begins, and then you piece together a big picture. That's one way of looking at it. Another way that systems, but that usually determines one small part of the great big whole, and then when you start gluing everything together, you realise it doesn't work because something doesn't quite fit. And that's where people start using modelling techniques and things to try and work out what's missing. Therein is sometimes a danger because you can fit all sorts of solutions to a model that don't necessarily recapitulate reality. You could, numerically, you could come up with a solution that is impossible in terms of what might happen to biology. And quite often people may not even realise that whilst they're doing it. But then the opposite end of the extreme, you've got systems biologists who don't worry too much about the whys. They just measure lots of stuff and fit it together and use it to produce predictions. So, for example, you could use mass spectrometry, and you might say, well, I've got two cell types, so one's misbehaving and one's behaving itself, one's a cancer cell, one's completely normal. What's wrong with these systems? And you might be able to measure 300 proteins in each sample and measure a chemical modification on each of those proteins. And you don't know what any of those chemical modifications mean, but it enables you to identify something about that cell type, that it's different to the normal cell type. And so systems biology, it means different things to different people, but some people, they're thinking about sort of big, complex data that fits together, that explains how something is, without necessarily understanding why that is. And that could be used in a predictive sense. So it's used in these sorts of approaches, particularly image analysis, are used by machines to tell whether the sample's a cancer cell or a normal cell or whatever. There are systems to do that. But then at the other end of the spectrum, and this is the area I'm more comfortable with, is trying to understand all the building blocks of a system, put it together and see how it functions. But your analogy is all about how things join together and how there's a consequence over here of two things happening over there, and everything's connected in some way.
Yeah.
So I can see it works from that perspective.
It's interesting that so part of the interest here is that the theoreticians don't think of needing to reduce their explanations to something else.
Yeah.
On the other hand, when just taking what John's just said, it's shot through with questions about whether it's working. I mean, your question in the end is going to be, when you say, well, what does it mean? What does it mean in terms of this system working and, of course, failing to work? Mm-hmm. And that I was wondering whether there's any sense in which one thinks of that system as working or not working, or whether it just does what it does.
Well, this, where is it? Hang on. For some reason, it's not coming. I'm jumping ahead to the next bit here. That button's not. Will this one work? Is this a completely separate thing?
Can you? Well, I was using the mouse. No, it's not a point. It's, you can go back and forwards here.
Oh, there we go. I see. Right. Okay. Yeah, I guess the question about whether things are malfunctioning or not, in this case, there's going to be lots of malfunctioning here because the people who are, the things that are doing this are agents, are humans. And so all of this is assuming that people are reasonably rational about what they're doing, so they're responding to changes in the economic environment, and so it's easy to get mistakes in here, and that's part of the other one of the moves in economic theory. Behavioral economics is trying to explain why people do irrational things, why do they end up making economic moves that really don't make sense given the objective states of affairs. So I don't think they would have too much difficulty working in mistake making into this kind of analogy. Mm-hmm. But it's also, although they always say economics is really, really complicated and there's so much to it's in a way much easier in the sense that we know what human minds are like, in the sense that we know them better than we would know bits and pieces of biological systems, presumably. We can empathize with them and we've got an idea of we're economic agents ourselves, and it's easier to get into them.
I mean, I would say two things. First, probably if you say system biologist, you probably don't quite mean what... I mean, you're more likely to find an applied mathematician if somebody calls themselves a system biologist than a proper biologist. I would say it's at least...
I don't think most people know what the word means.
Yeah.
I think that's the reality.
Anyway, so just a little warning, you might not get the person you think you're getting if you...
Right.
So that's one thing. The other thing is, I mean, if I'm currently actually reading a book on molecular biology, and you will get like something like this, right? Mm-hmm. This leads to that and leads to that. Mm-hmm. But, I mean, I don't know about this. But the difference is, if I ever look at one cycle of some things and then ask, well, what is this? And I can go to John and he says, well, here's the paper. And then he will have a very empirical, this leads to this, and this is how we track this pair. This extremely number theory, heavy experimental, here's 20 experiments at this, and here's the marker, and so we know this is this, and if you, so it's not foggy, it's just foggy when you kind of like step back and give the picture.
And the same thing for Fisher as well. I mean, he was heavy into the mathematics, so all of these points, everything would be, and he does the history of economics, he's relying on experimental data all the time. And it's more, and that's where this, one of the reasons why I like it is that it's empirically responsible, saying this is the best evidence we have about how these sorts of steps work because we've seen them happening historically, and he goes through various cycles of inversion. But the idea ultimately is that once you know the nature of these component parts, you can see why it has to go that way. Now, you wouldn't have been able to work that out as a metaphysician, you know, in your armchair saying a priori, these are the steps that are going to happen. That's not the picture. But once you get a sense of how these parts work, you can see how they hang together. And it's like, right, okay. There might be all kinds of times when those relationships are interfered with, and that's one of the reasons why running experiments is so difficult, because you never really know. I thought there was going to be this connection. It turned out not to be there in the results, but why? Was there some sort of obstructing factor and whatnot? So they kind of get away from the prediction side, use all the empirical evidence they can to get these sort of steps established, and they say, well, don't ask the economists to make any predictions, though. God knows how the real world will end up going, you know, 2 months, 2 years down the road. The only thing he wants to do, though, is the beginning, the first step.
Well, that is a prediction, isn't it?
The first step, yeah. The first step is as soon as you get heavy debt.
Exactly.
That's the thing, yeah.
Then it will go to X.
Then these things, yeah, assuming at some point you get this heavy indebtedness, these things are very likely to happen.
So it'd be interesting to know how the parallels are in this model with the uncertainty that you sometimes see in biological systems. So one of the problems, the way that the sort of simplistic approach to biological experiments have developed over the last 20, 30 years is that they are simple, and we tend to draw them out as linear pathways. So protein A binds to protein B, it produces this, then that binds to something else, it produces something else, and this causes the response. So it's a linear pathway of things that happen. But in reality, cells tend to, if you're just thinking about cells, you could think about a whole organism, I guess. But if you think about just a cell, they're rarely just responding to one thing at once. There's all sorts of stuff going on simultaneously. And many of the elements of machinery in the cell are shared between many of these other things that are going on as well. So we're better off describing the biology as a really complex network. So if you imagine everything's joined together in spaghetti and you're not quite sure, and therefore, what the consequences of interfering different steps in that might be, which could be analogous to something desperately going wrong in one, for example. But for the biologists, from my perspective, the place where this becomes particularly apparent is when you're thinking about developing drugs, for example. So you've got a complex system, and you say, well, this is really important, and this goes up a lot in disease, so therefore I'm going to design a drug that inhibits that, stops it happening. So you develop a drug, it inhibits that, but there's all these unforeseen consequences because of the way everything's connected together. And as a consequence, you kill someone, or you know, it's a disaster because you haven't seen the whole system. So how does that map onto this?
Well, sorry, can I just jump in if you've got that and say, well, isn't that one of the advantages of theory? You know, one of the advantages of theory is it's supposed to help avoid that kind of, I guess, wasted resources and wasted time. Just saying, let's try this thing, and then you find out a bunch of unforeseen things. If you had a theory which told you in advance, let's try and organise what we already know, pretty good bet that actually this kind of approach would lead to these unforeseen consequences. So don't even try it.
I think that's the whole direction that systems biology is moving in. It's mathematically modelling and using other fancy computational techniques to be able to describe what happens from the things we can measure and the things we know about. The problem is quite often there's loads of stuff that we don't know about, so therefore we haven't measured it, and so there's bits of spaghetti that you just don't know are there, and possibly quite a few bits that are in the wrong place due to misinterpretation or bad design of experiments. So that's ultimately where it's going. And actually, quite often it's impossible to do the experiments you'd want to do. And therefore, if you could model it, you're able to do something that, I mean, practically impossible. Say, for example, we might want to use a transgenic mouse, but it's impossible to produce a transgenic mouse that lacks the particular protein you're interested in, mutating the particular protein you're interested in. So as a consequence, you can never test that question out.
The problem is the theory is like nowhere close to, I mean, even if they have the data, it's hard to make predictions on a complex interlocking system with many gears and things, because it's extremely sensitive to anything, right? So it's an entire So like that's why I'm saying the theory is kind of in infancy, not because like biologists are dumber or something. It's just a much harder thing.
Yeah.
Physics is simple.
Just warm it up.
This
a bit
is
and
this
it performs differently. Cool it down a bit. It performs differently.
It's terrible, so, literally. So that it's not for the want of trying. I mean, you're completely correct, and that's often how theorists try to sell their studies to the funding agencies. They say, oh, we will, instead of doing all this fancy experimental stuff, we will just calculate it, and then if you look 1 year later, they kind of got lost completely in the woods and have no idea. Like they get some results, but they can be true or not true. And the next experimentalist goes along and says, "Look, I just did this. It's nothing like it," and that is that is the regular thing. This is not the exception. So that's why I was saying it's way behind. It's so hard. If this is actually interlocking, as you said, if there's some it's just what.
Yeah, I think this will be relatively, it's going to be easier, I think. I think the economics would be easier than the biology.
Ask Liz Truss about.
There is spaghetti involved in this as well, in that later on he takes you through the history of various depressions, and the steps don't always follow in this order. Sometimes there's feedbacks, and then you get back to
people
this.
start predicting what might happen, so they might behave differently to the last time it was done, because this all happened before, so their behaviour's different.
Yeah.
Knowing the theory, or knowing bits of the theory, affects the kind of behaviour
Probably
that
knowing a bit of the theory,
you... Which doesn't happen in biology, unless you're investigating,
I'm
humans.
not sure of that.
Platelets don't know what theory you're operating.
But there's confirmation bias, right?
There's feedback in systems though, like causal feedback loops. It sometimes is like memory or remembering how it worked out last time in a metaphorical way.
That's true.
So there's something to be said there, but I don't know.
And then does he even know all the cases where his theory didn't work? Because you might even not recognize, how does he spot? He sees depressions, right? So you might not always know, your cycle should have triggered, but it didn't. So you're not even aware, you're not even looking at it, because it's not limping up in your data, right? So
he's confined to going with historically recognized depressions and saying.
But that's like confirmation bias in a sense, right? Like when I see the massive depression happening, it went this pattern. Does that mean all depressions work like this? Does it mean it never gets stopped along this path? Because if it got stopped, then it didn't become a depression and you didn't see it. Maybe. I don't know. Maybe you looked at this step one and said, I'm looking at all the applications that ever happened. Then you have a chance, maybe. It's terrible.
I guess the depression is where the negative feedbacks become overwhelmed by stuff that happens. It's the system's no longer able to cope, so it just spills over.
And it's all meant to give government policy some guidance here. That these are the changes. You can interfere by doing this, that, and the other thing.
But that's also interesting.
Yeah, nobody listened to it. At the time.
Well.
Yeah, I wonder how you would describe the current situation in this framework. I think one might be something slightly different, but
if I was a politician, I probably wouldn't pay attention to that either. I'd be really worried about because the consequences of getting it wrong are massive. So it's like, I want to be really sure that this chain of events, this cascade of events really is going to happen, because otherwise, I'm better off playing safe.
Yeah, the over-indebtedness that's got everybody coming back to this theory, and the last bit was all the mortgage stuff.
Yeah.
In the
States. And all that.
Yeah. So heavily in debt, and then boom. And these guys are saying, oh shit, that's uncanny.
But none of this kind of model of this leads to this, leads to this, leads to this, well, correct me if I'm wrong, maybe it doesn't, maybe it does, but it doesn't seem to, on its face, to take account of the kind of meta things going on at the time, manipulation of the markets, and the kind of, there's nothing here about government policy, there's nothing here about monopoly behaviour, there's nothing here about predatory lending, there's nothing here about psychological manipulation, there's nothing here about anyone trying to corner the market. It's like, it's just, if this happens, that happens.
They would be variables on each of these steps, probably, wouldn't they?
Well, would they
so they'd be extra.
I mean, where would you fit in government manipulation as a variable in that? I mean, everywhere. It's like...
this was in the 1930s.
Which was less government manipulation.
Yeah.
But applied to, say,
the GFC.
Yeah,
I think you'd have to soup this up to meet contemporary needs. Okay, yeah, okay. Assuming that's all right, there'll be extra complicating factors now because the society's just so much more complicated than it was in terms of financial arrangements that we've got, financial system we've got. There's going to be other factors that we're going to have to guard against. But we haven't actually even got to reduction.
Yeah, we're getting there. We've blocked out the whole afternoon.
Well, we'll see.
You have to catch a flight at some point.
I've got a
okay.
flight, I've got a train and all that kind of stuff.
When do you need to go?
I need to be at the train station for about 6:30. So we're okay, right? It's only 3 o'clock.
Yeah. So just so you know the plan, we've got a place in a pub with a meal booked for 5.
Ah,
It's about a 20 minutes walk from here.
right. In the
And that
direction
will
of
be
town?
that way.
Yeah.
Yes.
No, that's
Julie Obscura. It's in Jericho.
Right.
And then so that if you left there about 6,
Yeah.
You
And you
should be
guys
fine.
can still be, yeah, you guys can be. Right, okay.
so we should finish about 20 to 5.
Okay.
And there's tea. I don't know if anybody wants to break for tea or
Yeah.
coffee. For
We
sure.
can just do it while we
just,
just
and just while we talk, just grab it.
Yeah, yeah. Yeah, on you go, Chris.
What?
You look like you were wanting coffee there.
No,
Oh, right.
no, just sitting forward in my seat, ready for the post-introduction.
Okay.
Picked a great day to record.
I'm not mastering this very well. I'm going all the way back to the beginning. God. Let's see how I do this. Okay, enough of that. Right, on to reductionism. All of this is kind of by way of saying, originally I was thinking of, it was going to be a fairly straightforward talk on anti-reductionism in biology. That's the challenge, mainly because you guys had said, look, we know that our system is pretty much, our proposal is anti-reductionist, apart from the idea that explanations of biological systems can be reduced to physical laws. And in the limitation section, it's like, well, we don't defend this, we can't do everything in the paper, but at some point, we'll need to do that and see what we can come up with. And I thought, yeah, okay, that's right. And there's a lot of different moves in the anti-reductionist playbook. The one that tends to fly best with me, and that I find most plausible, is something like the one-many problem. But it's based on this idea of classic reductionism's got these 3 main ingredients. So I think this will be interesting to see whether my ingredients are actually what you guys understand by reductionism. But I think essentially 3 main ingredients to reductionism. The first is that entities at one level ontologically depend on entities at a lower or more fundamental levels, so call that fundamentality. Hierarchy, entities at more fundamental levels are more explanatory important than entities at higher levels. And then one about the nature, the spatial arrangement of these levels. And more fundamental entities appear as constituents of entities at higher levels, located within the entities at a higher ontological level. Now, very often what you'll get is people making distinctions between ontological reduction, methodological reduction, explanatory reduction. And I see those kind of all piggybacking on ontological reduction, because reality, if something is real, it will be doing something, it will have an explanatory role to play. So if I get ontological reduction, then I should also have epistemological reduction, and that then motivates methodological reduction. So, try to get down as low down the orders as possible, because that's where the explanatory action is happening. Is that fairly uncontroversial to everybody? Right, yes, okay, good. Now, my understanding is that this doesn't fit particularly well with lots of instances in biology, because what an entity does seems to depend as much upon the context in which it's found as the nature of its constituent parts. This is this kind of the part-whole relationship of a particular individual. The nature of the whole will depend certainly on the nature of its parts, but what that whole will actually get up to is often more, well, it's context dependent. So finding one and the same entity at level 1 can be connected with more than one entity or process at level 2, depending on the context. So gene in this context might be expressed this way, but in another context it might be expressed another way, and then it looks as though, well, we've got something wrong with reductionism, because what's happening in causal interactions between entities at the same ontological level is often more exponentially important than what's happening between the constituent parts and the wholes, package, reductionism. Now, that's the kind of anti-reductionist ploy I have quite a bit of sympathy with. There are other moves. The move that would be made by functionalists in the philosophy of mind would say, well, there's a many-one problem as well. You can have one state at one level, ontological level 2, but it's realized in many different physical states at level 1, and so we should be expecting a one-to-one correspondence relationship between two levels, but what we're getting is either a one-many or a many-one. Boulter's examples that I can just recall offhand have never really sat particularly well with me. I'm hoping he's got better examples, but he talks about mountains, for example.
Sorry, who does?
Boulter.
Oh, Jerry Foder.
Yeah. You can have mountains. Mountains are one kind of thing, but mountains can be made up of all different kinds of stuff, and so that's supposed to be a many-one instance. I'm thinking he's going to have to do better than that. The other one he reaches for a lot is on the analogy of artifacts. He talks about mousetraps. Mousetraps have got a certain job to do, but you can make mousetraps out of any number of different physical items in various arrangements, and so there you've got another many-one problem. I just don't get it. That doesn't really work for me. But I'm not a functionalist in the philosophy of mind. But that issue, or they go, that's fine. I get that. I can see why that is a challenge to classic reductionism. Is that looking problematic? Is that looking safe?
So, if I can ask, so the idea here is that you're saying the many-one problem, the Fodor and causal role realization thing is you don't find that compelling.
I don't find it compelling.
But the form of anti-reductionism that you do find compelling is the idea that if I have an entity or a system and I'm looking at the system and I'm trying to explain its behavior, oftentimes what gives me the most explanatory purchase is looking at the interaction between its own parts less than its constituent parts, and maybe even those parts with respect to the environment as well. So it's kind of outward facing and inward at its own level rather than a...
Ultimately, I would want to say you're not going to get a complete explanation until you know what the constituent parts are doing with any particular whole. But if you want to know what the whole is going to do, it's not going to be enough to know what the constituent parts are up to. You're going to have to know what that whole is up to with respect to other wholes at the same ontological level as it, and that's where
Well, our draft
the
reductionism
context
paper,
comes
well,
in.
we make a lot of that in our draft reductionism paper, that very point.
I mean, if you want to, we've had lots of discussions on these points, so I can say quite a lot to that. One thing I would say is that whatever that is, it's certainly not classical reductionism as in what physicists have been doing latest since the 19th century or probably before. This is not recognizable to me as, like if I hear the word as reduce things, I mean, I have no problems at all with things working at different levels. I have no problems at all with environmental effects. That's like standard physics. Declare your system to be whatever you need for the explanation. So I'm not just saying that there might be like a level of this is philosophical classical reductionism versus this is what the sciences has done.
I'd be more than happy to concede that that's likely, because I'm more au fait with the philosophical literature, and so it could turn out that this form of reductionism just isn't interesting. It's not a challenge anymore, and if that's the case, then that's great news for the mistake-making project, because if that's what mistake-making is really looking for, and that's what it needs, then I really don't see there being too much trouble.
Well, I mean, the interesting discussion internal with us is, I think, okay, I'm kind of going ahead, but this more mild, this better form of reductionism, or what you want to call it, or this, whether that is enough, like whether that can still be challenged. Do you have to go beyond that even, or not? And that's more the discussion I think we've been having.
Going beyond what?
Beyond, assuming that you acknowledge that you can describe systems at various levels, and often it's not the best to go down to entities, which frankly is not something that anybody wants to contend in the sciences, definitely not in physics. I mean, it's well known that is, I mean, it's almost something you seek for.
So this phrase that seems to haunt philosophers then, that physicists just want to say that biology is just more physics, is that just fake news?
Well, it always depends on what you, okay, so here's my standard example for all of these things. That's thermodynamics and statistical mechanics, in particular in the example of ideal gas law. If you look at that's to physicists, that's what reductionism means, right? What you can do is you can take the ideal gas law, PV equals nRT, right, which is about pressure, volume, macroscopic things, and you can go, well, I'm now pretending atoms are little balls and they're going to bounce around, and you can do stats on that, and you can derive the macroscopic things. So you have reduced it, but nobody in his sane mind would do any calculation whatsoever with this gas cloud. The only thing you ever do is to show that there's an equivalence, and then you use the macroscopic things because you want to deal in pressure and things. So you describe it at the macroscopic level. You never do. There's other things you describe at the atomic level, but not this. And so what I'm trying to say is this is physicists would say, yeah, you can reduce pressure to the collisions of atoms with a wall. They would say that's clearly reduced. So in that sense, reductionism happens, but it doesn't happen in the sense that you actually want to do it. You're not trying to explain things in terms of this, except for very rare cases where you have very special things.
What about
But just our position on mistakes is stronger than that.
Sorry?
Our position on mistake making is
Yeah, that's what I'm saying. What my point was, I'm saying this is the reductionism that I mean when I say reductionism. And it's, I think at the level that you're having, I'm completely happy with that. But
that's the kind of reductionism that you describe, e.g. with gas pressure and so on, is not the sort of thing that keeps philosophers of science up at night, put it that way.
Yeah.
The sort of stuff that keeps philosophers of science up at night is the thing like a question such as, is there a complete description of biological phenomena in purely physical terms?
Yeah.
And by description, we mean something ontological, not just like, can anyone describe it? Is there anyone smart enough? But rather, in principle.
Yeah. So what I'm trying to say is, like, when we kind of discuss hotly whether reductionism is true, this is the sort of thing that I mean by reductionism, right? And the question is that enough to say everything about the world? Or do you need more than that? And that's the question. That's a tough question, much tougher than this stuff. I mean,
do you think most physicists actually ever think about this? I mean, if you were to ask a physicist, could you reduce most biological processes to physics?
They would
They
say
would probably
yes.
say yes, wouldn't they? Because you could take any process and, in theory, explain it by physics. But I guess what a biologist is thinking about is variability, the way that things don't do what you might expect them to in certain circumstances.
But the
It's
physicists
much
would
more-
never pretend that they even have a shot at this.
No.
So what they literally mean is exactly, it's like us.
terminology
Yeah,
difference.
it's just literally like us, and then, okay, so the biologist is like the person doing thermodynamics, right? And you ask the physicist, can you explain this in terms of the atoms? And the physicist says, even though they actually can't do it, they said, given that we've done this before, we probably can do this somehow, but they don't pretend that they actually have it in their hands, and they probably wouldn't even try, because it's pretty clear that it's dumb to try this. I mean, it's you're not gonna get.
You won't succeed.
Yeah, but
That's
it's
what
like
I'm
just
trying
not
to
useful.
But
I mean,
I think
you're spending a lot of time
that's what's
to get
important
nothing.
here, though. Is this because you used the phrase explanatorily important? Like, is this a kind of methodological argument against reductionism? I mean, obviously it's just starting out, but I'm just.
It will be.
Okay.
It'll end up saying, look, don't be thinking that just by going down into the constituent parts you're going to be able to do everything.
Yeah, because I think maybe that's where, because I think I'm guessing that Ingo is thinking, well, sure. I mean, I have, even if I'm a dyed-in-the-wool reductionist, like, I'm not going to say that, like, if you want to know about market fluctuations in the economy, you should be looking at quarks and leptons or something. Nevertheless, I'm a reductionist, you know.
Yeah, and we're going to get to a big quote eventually, where it just looks as though reduction is just meaning too many different things, and it's no longer a particularly useful idea. I think that's ultimately.
We find out with the term function, in terms of the function terminology in biology as well, that it means just too many things.
But just on the thermodynamics one, temperature and pressure and all of that kind of stuff. In the classic stories I was told, the reason philosophers take it to be so significant and serious is that prior to that reduction, we were talking about caloric. There was some fluid that was supposed to be in charge of. And now we don't talk about caloric anymore. And so the interesting thing about the move, whether you actually do the calculations or not, is that nobody dreams about caloric anymore. That's been completely removed from anybody's ontology. That's.
I mean, if you again, we're kind of like back to what we were discussing earlier. So you're right there.
Yeah.
Though I have to say, in my physics education, I can't actually tell you the impact of caloric because I've never been told how people used to use. I mean, I know the word, that's all I know about it, so I have absolutely no idea how people actually used to do thermodynamics before.
Yeah.
But you're not being told that when you're doing physics.
Yeah.
You're learning the modern picture, right? So, I don't know.
But this is a standard example that's used in the philosophy of mind when you're trying to explain the identity theory and the relationship between mental states and brain states is, we used to think about caloric. It's not like we've given up on mental phenomena, but we just think they're brain states now, in the same way that, we used to think there was this 10% caloric, we don't do that anymore, blah, 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 blah. And then that's the classic reductionist ploy. And I think that's why people get scared, because if a favored item starts to disappear, that's when they start worrying that physics
Well, but is it disappearing? I mean, I don't know about this. It's kind of a hard thing to say whether.
If you're a dualist, then it would look threatening. Yeah, the identity theory it's not just getting rid of caloric. I mean, who really cares about caloric? But if you can do that for the mind, say, well, we don't need to have this immaterial mind that so many of you people are brought into. We can just do it with the brain. That's the kind of reduction that's going to get people.
I maybe, but okay, are you scared of nuclear forces, for example, don't exist? They're not existing. For the chromodynamics exists. Nuclear forces do not exist. There are pretty much an effect, spill-out effect from chromodynamic objects that leak out, right? But nobody knows how to do that, but everybody thinks you can reduce one to the other, right? So now, do nuclear forces exist or not? Well, you can do a hell of a lot of nuclear physics with them, right? And actually, you definitely nobody knows even how to do quantum chromodynamics to do this. So tell me, are they existing or not, right? I mean, that's what you're trying to say reality, and I'm saying I want to calculate whether that thing is going to split or not. right? And if you're at the level of, I want to know what this is doing, then the correct paradigm to use is nuclear forces, because they're there, I know what their rules are, I can do this. Whereas the theoretical reductionist picture might be there, it's all quarks and gluons, that's the ultimate reality, but this ultimate reality is basically useless. So I cannot at all, in any way or form, get to, so, you know, I mean, you tell me what is real in this case. Is it real just because I can imagine that...
You were supposed to be doing that for us.
I don't know, I mean, I have a job to do, I calculate the bloody
Now you're
thing.
telling us we should just go back and do it ourselves.
Take it all back. Lots of us should just take it all back.
But I mean, that's your job, to be honest.
Oh wow! Don't say that. We will.
I mean, yeah, so I mean, the important thing, and I think one of the things you're bringing up, Bingo, and you're trying to stress, Stephen, is whether or not you go into the type of reductionism that's eliminative, right? Because sometimes, in philosophy of mind at least, that sometimes this idea is, well, I can reduce mental states to neuron firings in the brain, and like even if you think that's true, you might think, but I don't want to get rid of the brain, or so I don't want to get rid of thoughts. I want to keep that in my ontology. I want to say that there are real thoughts. But some people have the idea, well, you know, if I can do such a successful reduction, even in theory or practice, then like the upper half's got to go.
Yeah.
And that's the problem. And so you might think, well, let's just keep the upper half, keep the lower half. It doesn't matter. But
Do whatever you want, yeah.
Yeah, but I think, you know, and some people are still reductionists while keeping both things. They think the top half is some bubbling cream on the top of
And
you know.
the eliminativist thinks that's achieved. You know,
Exactly,
That's achieved.
yeah.
Really, if you logically take it, you should get rid of the upper bit.
Right.
But the thing is, the reason why you feel free to get rid of thoughts is because you don't have to do anything with them, right? I mean, if you eliminate them because you're not doing anything with them. But
Right.
if somehow you had to operate with thoughts a lot, like you have to
I
we
do personally.
Yeah, like we do all. Like we have a mental mind that
Yeah.
people think things,
Yeah.
and that's important because otherwise you can't predict them.
Yeah.
So as soon as that happens, you can't eliminate them because they're like your working substrate, right?
You're not suggesting then that you, well, maybe you are, that you go with you cut your ontological cloth to suit the situation. Yeah, okay. You are an instrumentalist then. It's just, as long as, yeah.
Well, I mean, as far as my science goes, I mean, whether I have the same thing as the ultimate thing is a different. But if you're talking about me in science and what I mean with reductionism, I mean that's not just my idea. This is basically what they beat into us for like many years when they do physics. Stop talking about X. But this is your task. Finish the task. Don't talk. You know, like here's what you got. Solve. That's all. If you're done, you're done. It describes it. Next, right? And if you deviate, it's like bad. Don't do that unless it points you to something better to do. New practice.
To do.
I mean, you can speculate about reality, but only to get to the next level of practice, not to do da-da-da.
Science isn't really not in the business of understanding the world then at all, really. It's just about controlling it and making sure.
It depends on what you mean by that. But yes, I think in the way that you mean it, I think no, at least not physics.
But I mean, look, from the point of view of the Mistakes Project, you know, I mean, yes, we have a paper on reductionism and we have very strong views, particularly Jonathan and myself, and I think Christopher, and, you know, and there are disagreements, but, you know, we've all around the table have views about reductionism, we're ontological, methodological, no reductionism whatsoever. I mean, the paper is which I don't think you've seen. It's under review, and that's you know, strongly ontologically anti-reductionist. Although under Ingo's influence, we've toned down some of our language and the way we've presented it to. You know, it's not like we've got a knockdown argument. It's not a lot of knockdown arguments in in a lot of these areas. But from the point of view of Mistakes Project, I think you know some of these things can be bypassed in the sense that what made our project, I think, so attractive to our funders and what we find interesting about it is what can be done with it. You know, that we think that we have a framework for actually giving biologists such as our biologist, John, our world expert that we test everything on. We test everything
World
on.
experts on one subject.
Well, you know, if it passes muster with you, then we think we're okay. Is to be able to generate hypotheses that you can actually test. So with mistakes, it's not just, well, mistakes prove that ontological anti-reductionism in biology has got to be right. Well, you know, maybe not, but the point is that even if it doesn't, if Ingo thinks, for example, well, I actually think it's all physics, but to be honest with you, when it comes to calculating, shut up and calculate. I can't do it just on physics. I have to build teleological concepts like mistakes and correctness into my modelling or into my experimental framework, then yeah, that'll do.
Actually,
That's good.
sorry, I'm talking too much.
Is that a fair?
No,
Is that a
no,
fair?
it's very fair. It's
representation?
just one thing I would say. The reason why I'm really thinking that maybe, maybe all this stuff they're going up with is actually true in your sense, right? And this is a funny twist on this thing. If you're instrumentalist long enough, anything that works becomes true. So because, well, I mean, like that's what you do, right?
Yeah.
If you do that long enough, and that's why I'm kind of open to the idea that actually maybe it's not literally in your sense. It's not all physics because this stuff works, right? I can take these concepts that they have and do things faster, better. And if I'm a proper instrumentalist about doing my science, how can I take this whole thing that works and say, I ignore this, or I extend it. It is at the same level of, like I get progress by doing this. So, as for my principles, it's true.
This was one of the reasons why I was really really keen on the paper, is because it was methodological, wasn't it? This is a way to start thinking about research questions and formulating research questions. There aren't a whole lot of metaphysical positions that can claim to do that. That, for me, is what's so interesting about this.
Well, that's our ambition. I mean, I think that's our biggest ambition, that we will get together with people like John and other researchers and say, these are the hypotheses that this framework will generate out of your work. Is it interesting?
Yeah.
No, just on this, I mean, one of the things that the ways we have gone in the paper is not in terms of level, and that would be a question. I mean, and I don't know. This is a question, not implying I know the answer. Do we have clarity over what people mean by level when they use the term?
Well, the way I've been understanding the philosophers when they talk about this, it goes back to that spatial relationship between parts and wholes. So the level always seems to be, you've got something small, it joins something else, a whole becomes a little bit bigger, and so that's the new level. Why? Well, it's got parts that it didn't have before, and so it's not just a matter of complexity, but it's got something to do with the number of different kinds of parts that you've got. Seems to. So, all right, if you go for the ultimate move here, the basic level would have no parts. They'd be completely simple, and then subsequent levels somehow are adding constituent parts to it.
God.
Well, in the old days, when you talk about
That's
the
right.
ontologically basic level, they would be God, and one of the classic moves of describing God is that, God is simple. That's why the Trinity was such
Oh, yeah, that's what I'm getting at. Then if you're going that way, that's like you.
I don't know you, Stephen, or the more I think about levels, the more I actually hate them. I mean, I used to, you're brought up on levels, certainly philosophically, you're brought up on levels when you get introduced to reductionism, and you get introduced to mind-brain identity theories, and then all the stuff on fundamentality that people are doing nowadays. It's something that you just take in. There are levels, and we think, well, physics is this level, and then you've kind of got chemistry, and then you've got biology, and then what have you got after biology? You start to get maybe into maybe you've got, maybe some of the animal sciences, sort of various versions of biology at a higher level, and then you kind of get into the human, and you have things like economics and, blah, blah, blah. The levels, do you think levels were invented by reductionists?
I can't blame everything.
No, that's a hierarchy. The Great Chain of Being never, the Great Chain of Being historically never had, it's the small things at the bottom, the big things at the top, or the physics at the bottom, the human at the top. Yes, there were scales and the simple and the complex.
Sometimes dependency relations as well. But,
yeah, but I mean, even the idea of dependence. I'm not trying to get all kind of monistic about it or anything like that, don't get me wrong, but the whole idea of dependence seems to me a reductionistic concept. It's a problem made by reductionists to bamboozle non-reductionists into thinking, shit, there are levels. Physics is at the bottom, so shouldn't physics explain everything else? you immediately buy into a certain kind of ideological outlook, as it were, with a small I, that tells you that really what you should be doing if you're serious about this is you should be starting with the physics and looking at what physics can explain, rather than taking, I think what you use in your, we'll get onto, the ontological layered approach, which I think I like a lot more. Layers are better than levels, I think.
Well, I tend not to think about, here's one level, here's another level.
Yeah.
I tend to think it's just all kind of it's not a mush, but it's just all kind of one level, and you can break it down into smaller parts, and then you make up bigger parts, and those parts. So,
and the layers are all intertwined, like a cake.
yeah.
Sorry, a bit metaphorical here.
That's a bad cake if they did.
Yeah, and the whole bottom up, that's got to be metaphorical. That's metaphor talk.
Yeah, but nowadays, this fundamentality stuff, and is there a fundamental, endless papers written on is there a fundamental level, no one explains what they mean by fundamental. Microphysics, it's microphysics is the fundamental level.
But there is the spatial argument, right? I mean, it's not nothing.
I think
it's like literal. It's like quite literal. I mean, there's big things, there's smaller things. You look with a microscope, they're even smaller. You tear that apart with an electron microscope, it's even smaller. You go into that, and you have atoms. And well, I don't know. That is.
It's true, but what? So what then?
Well,
I'm not saying they may not be.
It is a constituent
right,
layers in a spatial sense. That's quite clear that exists.
There are big things and small things, and philosophers like thinking about middle-sized things for the most part. And occasionally.
Okay, I don't mind that. I'm just saying you can't say that doesn't exist.
Why should we privilege the
Yeah, but the
small
jump,
over the big?
yeah, exactly. The jump is thinking, well, of course I can go down and see things smaller and smaller, but you can go up and see things bigger and bigger. And the question is, why are you privileging smaller over larger? It has to be because of explanatory reasons or methodological reasons. You're thinking, I can explain the larger in terms of the smaller.
Again, if you're simply thinking in terms of here's my arm, it moves through, okay, so if I look at it, there's cells in it, so in some sense, if I have all the motions of all the cells, I have the motion of the arm for free, right? That's just true.
Well, if I have the motion of the arm, I also have the motion of all the cells for free.
And the atoms inside them.
The way we've been thinking in relation to clots, it seems to me that I don't know whether the notion of level quite works, but you can say that we need to attend to the question of how you achieve a good clot. And in that sense, you could say, well, there is a level, and I would say it's a normative level. It's a good clot versus a failing clot. But how that's achieved potentially is still up for grabs. Now you could have something that looks a bit like higher level regulation. If there was some observing capability, like in the cardiovascular system, for example, that monitors the effectiveness of what you're doing, and we speculated in the paper as to whether there may be some neurotransmitters hanging around that might actually do this. Equally, it could be that something goes on between platelets, some sort of signalling that, to use the term very loosely, keeps an eye on where it's going. Now, I would say the thing that's a bit like a level, although I personally wouldn't use the term, is where it's going. But then how you get there, potentially, even seems to me with a clot, still open to all sorts of possibilities, including very local arrangements, or something like that, working off a predetermined template, or some kind of process that monitors progress and alters things iteratively as you go. So, in a sense of level, where's it organised? It seems to me one can't know that ahead of observing it. In terms of the sort of overarching principle that it's going somewhere, and it will achieve that better or less well, perhaps that's a bit like a level. I mean, we would put it in terms of normativity and correctness.
I haven't heard of the normative levels before, at least not in this context.
No, it may be just a different concept.
We should
Yeah, I think
move on with your other one.
Right, let's see if I can get it to move. Right, this is where I change gears, because Ingo's comments are actually quite encouraging. I give just the bit of reductionism that I'm happy with, you seem to be giving me for free anyway. And I'm not sure, you guys can tell me whether you need anything more than that to get what you guys need for the, I didn't think so.
Probably not, strictly.
And then then I say, well, so where's the problem then? I don't know where the problem is. Well, and that's when I started worrying about what people are doing in philosophy of biology when they've gone with the anti-reductionist program and then they're just running with it, and they seem to be going in, well, in strange directions that I wouldn't be recommending for any number of reasons, but certainly not for metaphysical reasons. And then the worry ultimately is that, well, if they're doing wingnut stuff, is that going to bring your project into disrepute because you're going to be, now, maybe you can't do much about that, but if you can differentiate yourself from other kinds of anti-reductionists, then maybe that would, you would be forearmed there. But this is a quote. Started looking into all this, and the Stanford encyclopedia entry on reductionism biology ends one of the sections like this, which essentially has this quote at the bottom: "We should move beyond reductionism entirely." And this was a summary of all of the reasons why people within philosophy of biology have been saying, look, this isn't working. Now, they have more reasons than I'm entirely happy with. For me, it was really the one-many issue rather than some of the others that they're on. But they refer to something we've already been talking about. Once we incorporate distinctions about different types of reduction, ontological, epistemic, methodological, different interpretations of these types, the different representational features involved, and the distinct biological topics to which philosophers apply them, any single conception of reduction appears inadequate to do justice to the diversity of the phenomena and reasoning practices in life sciences. The multiplicity and heterogeneity of biological subdisciplines only reinforces this argument and suggests to some that we should move beyond reductionism entirely. And then the sum turns out to be actually just most. I think this is a classic case of a philosopher being safe. I don't want to overstate my case and stick my neck out and be, but there's a lot of mainstream philosophers of biology who are looking at alternatives now. And that's when things get a little bit interesting. So there's one group that I'm just highlight, but it's not. I don't think this is the main worry. But there is this push to say that reductionism generally is an ideological, political, patriarchal, all that bad stuff, right? And so wanting reductionism in biology is just more of that. So we've got to change our ideology, change the biology, and I just find that alarming because I don't want my politics to be influencing biology. I just don't think that's right. That's just, yeah.
Yeah.
Why would I say
Now you just
mainly,
speak for anything else.
yeah, mainly because, I think the natural order is mind independent for the most part, and it's got nothing to do with what we would like it to be or what our political ambitions are. It's just totally irrelevant. I accept that's a metaphysical claim about mind independence of reality.
Even if you see a mind dependence, I would say what wins in science is what's most successful, end of story.
And then everybody's saying, see, there's the patriarchy.
I don't give a damn. I'm still faster than you in predicting, and I'm faster than you in predicting. End of story. Like I mean, that's just.
You are right, Stephen, to highlight this. Something we really thought about much, but you are quite right to highlight this kind of ideological aspect of the term reductionism nowadays.
Well, I have to spend quite a lot of time in my lectures getting. I have students who use oh, that's so reductive.
Yeah.
As though immediately
Yeah.
it's a bad thing, it's pejorative. It's like, well, hang on, don't throw it out that quickly.
And what they mean by that when they say that's so reductive is here's my reality, and you're trying to make it something else, and you're denying my reality.
You're not letting me have my identity, you're not letting me have
my view, or whatever it happens to be.
You're shutting me down. And then you can, well, you start going that way, you're free to say whatever you like.
Yeah.
And that's, yeah, okay. So,
This is sorry. This is a real paper. This first paper.
these are real papers.
Okay.
Yeah.
It might not be one of those troll papers that occasionally gets submitted.
Well, I mean, I don't know. Yeah. Okay.
I quite.
This is so cold.
It sounds very funny. I want to see what that says.
Yeah.
There's,
I don't really read
there was a
feminist
Twitter account which I think's been shut down, of course, as really, because anything interesting on Twitter gets shut down, called Real Peer Review. Did you ever know that?
No.
Yeah, it's called Real Peer Review, and it would be listing these papers as soon as they come out. You know, well, that's completely sane.
tame,
That is
yeah.
orthodox compared to some of the. Do you know the account?
No, I can imagine. Yeah.
Yeah, that's nothing. That's tame, you know. And some of them, I would imagine, are troll papers that have been generated by AI algorithms, but a lot of them are just real papers by real people out there, you know.
Look at it, this is Harvard.
Yeah.
Princeton.
Yeah. Well, Lewontin, of course, was a famous kind of, you know, for his left-wing politics. So, I mean, for him, politics comes into evolutionary theory at a very early stage, right?
Yeah. So that's 85, that's an early one. But yeah, so he's going to be feeling good if he still lives. Is he still lives? I'm not sure.
I think he is. Yeah.
You think? Is he? I thought
He
it
is.
was. Well, okay. But, yeah.
So that's one kind of excessive anti-reductive. Really, that's. I don't really want to spend much time on that. It's Dupre.
Yeah.
Dupre. He's more of a more serious person, and he's been banging on about this for a long time. He's got this new everything flows, which is really makes for extraordinary reading. If you haven't had a chance to read it, you can actually get the PDF for free, so you don't need to spend the 80 quid. But that's the recent one, 2018, everything flows. But he's been doing this since the early 90s. He's read The Disorder of Things. I mean, that's the worry for me, because reduction, whether you like or think reductionism can be pulled off or not in one form or another, at least the motivation for me was always a good one. You're trying to keep
system and all that.
keep the world coherent place, and hopefully we'll be able to make sense of it. Yeah. But this is metaphysical foundations of the disunity of science. And he's not just saying, I don't know how to harmonize the various branches of science right now, so it's just an epistemological point, and that I don't, eventually maybe we'll get to a stage where we can unify those. That's not what he's going for. He thinks it's not about the limitations of epistemology, it's something disordered about the natural world. I find, well, if that's true, then you've got one of the most interesting arguments for skepticism that you can get. It's not about, do I know there's a table in this room or anything like that. It's starting to deny that there's order and system to be found in the natural world. And for me, that's essentially what the sciences are about.
I don't know enough. I've read parts of that. I've read other things on reductionism by. I mean, he's written some good anti-reductionist stuff actually. But yeah, I mean, so I know this, but I don't know his work extremely well. To what extent do you think Dupre's view and his process on, the process biology, which he's pushing and various people he's worked with, is influenced by the kind of the Feyerabend, Kuhn-Feyerabend school of sociology of science kind of, or is it just a different take?
I think it's different. I think it's based on metaphysics. In the chapter, the opening chapter to Everything Flows, it's a manifesto. I think that's how he puts it. Manifesto for process biology. And the bugbears are reductionism, essentialism, and mechanism. And he doesn't really bring in Feyerabend, he doesn't bring in any of that kind of sociology stuff.
So what's left?
Well,
processes.
It's,
Yeah.
yeah, the,
He
essentially,
sees process is order, it's not a process.
the world is made up of goings on.
Yeah, but they're still going
Yeah,
somewhere. I mean, if it's
I agree.
But
Well,
there,
yeah, you don't need to convince us.
there are no,
But
there are
if
no
it's the
things that are getting up to stuff.
yeah.
There's just goings on. And it's a mistake to think that, so the phrase that Johanna Sieg uses is, and she's not the only one, but it was this,
Well, and Sophie Mikey, who's a postdoc, was a postdoc from she's really pushing the process on biology as well.
the subjectless action. You can have an action without an actor.
Right. Fine. So I mean, again, I'll ask, what is your, I mean, what's the consequence? Like, because we're getting back to, you know, like that's fancy words, what are you actually doing in the end with them?
What he he does this. These are some of the implications of the process biology. He goes for what he's calling promiscuous realism.
All right.
So there are no distinct biological species. All right, so he's having a hit there at essentialism. I don't think he's ever really understood essentialism in
No.
the way I would understand it.
Yeah.
There are no, this is more worrying, there are no distinct individual organisms.
Yeah.
Okay.
So the kind of classic tripartite distinction, I mean, I published a paper in his collection on this, and, you know, we had a lot of toing and froing on it, and he was very nice about it. He's a really nice guy, so it's like, he wasn't like saying to me, you know, rubbish, you know, he's just trying to push back, and we're pushing against each other on this, but, you know, the tripartite distinction between organisms, parts of organisms, and pluralities of organisms, populations or whatever, is just completely collapses, you know. You can't mark the boundaries of an organism, everything, you know, what you think is an organism actually could be a colony of organisms, which are themselves colonies, which are then parts of, and it's completely...
So is he not considering himself as an individual organism?
Well, look,
I mean,
he'll give you a
because-
reason. He'll give you a look. Some of this stuff actually raises extremely interesting metaphysics. So what, you know, I think we would probably all agree that some of these really extreme positions in generally in philosophy and in metaphysics do force people who hold the opposite view to kind of defend themselves. That you have to think about, like, for example, the whole gut microbiome and all this. So in fact, they love pointing out to you that you think you're this organism, but actually you've got gazillions of bacteria and other organisms inside you on your surface, burrowing about inside your body. Well, and humans have always been like that as long as there have been humans. Why should you think there's some individual organism there rather than a colony of organisms? You know, in all the...
It's very...
Could be!
It's quite simple. I'll take your wallet and see what you think. I mean,
That's not that's
Well, but it
like
is
Dr.
true.
Johnson, you know.
Yeah, the stone, I
keep
know.
the stone. Yeah,
Yeah,
okay.
but you know, I mean, it
It's not gonna.
works for me.
Yeah, but it's not going
It
to
works for him
It's
too.
not going to.
I'm pretty sure it will work for him very quickly if you go down that path. So
Yeah.
Ultimately, all that gets to why he doesn't like reductionism.
Okay.
Essentially, there's nothing to
There's
reduce.
nothing to reduce and nothing to be reduced to.
Yeah. Although he continues to talk about a hierarchy of processes, which I have difficulty visualizing. I'm not sure. But he's picking up, Whitehead had this process.
This goes back a long
Yeah.
way. Whitehead, as in, remember,
Yeah.
goes back to the 1930s and probably goes all the way back to Heraclitus, if you want to go all the way back to the pre-Socratics, you know, this idea, everything is just, stuff happens. Stuff happens.
well, you know, I mean, there's moves like this, and like in physics, for example, you switch between a positional argument and a momentum argument freely. Like you have two different ways of describing quantum states. You either say stuff is there, and then you describe momentum as an operator on it that moves it about. Or you say stuff is moving, and you describe position as an operator on that, and you kind of flip between these totally different ways of looking at it. So you could potentially go like, I don't care about things, I just care about what they do. I mean,
The way you talk about it, in my ears, it sounds like instrumentalism. You're saying,
like, well,
choose
that
what you
seems
like.
to be the case.
But he's calling himself a promiscuous realist.
Okay.
So, effectively what he's saying, this could be a cucumber, it can also be a carrot. It could also be a budgie.
Okay.
It can be all of them simultaneously. You just jump and change, but that's what he's saying. That's what he means by promiscuous realism. So an individual organism can be in multiple different kinds because there are no essential features.
Surely he would say they're different because they're different processes.
Say it again?
Surely he would say they're different processes and that's why they're different.
Well, he doesn't.
Well, then he's like he's just easily. I mean, again.
Well, the thing with Dupre is, and all these process ontologists really, is that they start to, not only did they question things inside of you, right, but they also expand it outwards because it's involved in different causal nets or something. So once you go process fully in your ontology, you start to expand out individuals, and then they expand out into populations, and they expand out until eventually you have nothing. You have, in a sense, you have a gigantic mesh of causal goings on, and the promiscuous part is meant to be like, oh, you want to call that an object? Sure, but so's this, and so's this, and so's this, and you can draw the line wherever you like because you're still casting a net and getting part of reality. So all good.
And does this framework have any normativity? I mean, do these processes succeed or fail, or do they just do?
I mean, they are. So I mean, some processes in general have goal-directedness to some degree. I don't
he
think
doesn't reject teleology. He's not a teleological skeptic or anything, is he?
But I mean,
what do you think he
I
is?
haven't
Maybe?
heard him saying anything about mistakes. To be
no, not mistakes. But he thinks that like if you try to get someone to say what a process is, part of it involves like the causal actions that are happening in it, and part of it is about what those causal actions are doing, in a sense of what they're supposed to be contributing to as a goal. But again, it's not. Again, you can widen the net and say, well, you know.
If I take you versus you plus the bicycle out there.
Yep.
Well, I've made two nets. Now predictions on what you're gonna do are markedly improved if I just look at you rather than you and the bicycle. Or at least there's nothing that this bicycle adds to it. I might as well drop it. Anything that I can predict about the system of you and that bicycle out there, with very rare exceptions, is entirely contained by just looking at you. So I would say you can do this. It's just dumb. So we know what.
I mean, I agree. But the idea is not just about predictive success, though. It's also about like causal entanglement to some degree.
Well,
and I mean, again, you can draw a realistically fine
it's true,
line.
for example, your atoms are not, you're not really contained in an atomar sense. You spread a lot of stuff from you constantly that goes out in the world. And so in a purely atomistic sense, I have no idea where exactly you are. But that is still a very yeah. I mean, there's lots of you everywhere, right? So, but that is kind of also a very useless way of thinking about you for most things.
Well, to be fair to him, he is saying that this metaphysical system does more justice to current biological thinking than substantival ontologies that think that there are things. So he is making a case that, look, I'm familiar with the biology, I'm telling you a process ontology fits that better than the
Okay, so what's his argument there? That would be kind of interesting.
Well, he has to take you through all kinds of stuff. He often points to the difficulty of drawing, as you were suggesting, individual, like lots of trees. You look at, I think aspens is one of the ones that he seems to like, and they're all connected. Their roots are all connected underneath. On the surface, they look like trees, individual trees, but underneath they're kind of connected. And then similarly, there's mushrooms. They often have mushrooms. Mushrooms are weird. And it's hard to count mushrooms. And,
Oh, fair enough. I mean, that's.
And I mean, you can run it outwards as far as you like, right? You can say something about why does the mushroom look like this? No matter how many there are there, why does it look like this? Well, it has to do with air temperature. Like, why is the air temperature like this? Well, it has to do with the spatial regions of this valley they're growing in or something. And so once you start having a criterion of identity that involves like causal determination, like I determine the boundaries of me are the boundaries of what I causally control, as it were. Well, all of a sudden, now you've got air temperature, now you've got valley shape, now you've got
Yeah, that's okay.
Yeah. I
Well,
mean,
It's
that's,
not okay because one thing it does is that it confuses and conflates, you know, entities with background conditions. You know, so given that everything causally interacts with anything, then background conditions causally interact with things as well. But that doesn't mean that those background conditions are part of the things that they interact with. I interact with oxygen doesn't mean that oxygen is part of me. So you know, it just blurs those boundaries.
yeah. I mean, that's the. I feel like that's the.
Okay, I'm not talking about.
Not the best example.
I'm not talking. Yeah, I'm not. I know you were going to say that. I'm not talking about like the oxygen that's in my cells and all that stuff.
Yeah.
I'm talking about the kind of the stuff that just goes in and out through respiration.
Right, yeah.
If I take a gulp of air, that air is not part of me. You know, it's not like when I blow it out again, I'm like losing a hand or something like that. You know, I'm not having an amputation of oxygen. It's
Well,
just I'm expelling a
Yeah,
gas.
but the oxygen just get incorporated into your amino acids and your lipids and.
Oh yeah, those bits maybe sure constituents and what have you, but I'm not trying to deny things like that. I
mean,
just mean that.
Yeah, either way, that's the kind of like seesaw that the debate is in, is whether or not we are fine with saying something like, oh, anything that has some significant causal import with respect to my development or maintenance or whatever gets to be included into me, or at least reasonably, like, and I'm allowed to draw that net ontologically, or whether or not you think, no, there has to be some sort of distinction here between what's really me and what is enabling me or like helping me or aiding me or etc.
Okay.
So I mean that's the way it goes if you're thinking
He
about.
pushes on all of that.
I mean, I'm kind of more comfortable, frankly, with your explanation there. I go like, I can sort of live with that as long as you tell me what your question is, right? So it might be entirely valid to say for certain things that you want to talk about, it is not useful to say talk about you as an individual. It's more useful of you, of all people sucking in oxygen and being in a valley
The
shape.
ultimate
I mean, there
practice.
might be questions where that is relevant,
Yeah.
right?
You're like
So- whatever.
the shit that you're like the living embodiment of the whole American pragmatist tradition.
I don't- I mean,
you're everywhere. You're Dewey, you're Peirce, you're.
I don't know. That sounds
Quine,
interesting.
you're
Maybe I should read them.
Ultimate pragmatist. Is it useful? Who cares whether it's is it? What can I do with this thing?
Well, but I mean, how are you ever going to stop this? That's what I'm trying to say. You can't.
You stop it with philosophy. You stop it with philosophy. That's
How
why
are you going to
the world
stop?
needs philosophy.
Because he can always redefine whatever you go. Like you
Well-
say, that's what he just did. He said, okay, and how am I going to argue? Like, in the end, how can I make a causal definition? That's like that's a,
You
Come up
fight
with-
philosophy with philosophy.
okay, fine.
You gotta come up with a different notion of individuality. You gotta come up with a different notion of causal dependence, which
Yeah.
makes better sense of the objects around you, which does better. I mean, I have a paper against this process view on different.
I read that one.
You have read that.
I have read that. That's a good one.
Which is exactly going against this idea.
Okay.
And
Yeah.
what's your argument against it?
Well, I'm not gonna. It's not my turn.
And just to say, just because John Dupre, you know, with all due respect to him, because he's no fool. Just because John Dupre says that the process biology better explains the biological phenomena than other things, doesn't mean he's right. Right?
Yeah, okay.
The devil is in the detail. You know, you don't just say, well, mushrooms. You know,
Yeah, now you sound like a
need to.
pragmatist.
You need to. No, I'm not talking about. I've nothing to do with pragmatism. It's to do with the facts. What are the facts? Like, you know, so with mushrooms or whatever happens to be, or orchards and groves of trees, it's the fact. You have to look at the fact. Just because he says, it's better, you know, if we look at it this way, doesn't mean that it is.
You've written a paper on him. There are times when I'm not entirely sure how serious he is about it.
He's very serious. Deadly
Yeah.
serious.
Because there are times when it sounds like it's a methodological suggestion.
Nope. He's a dyed-in-the-wool
He's
ontological
really-
process
Yeah.
realist. Yeah, I mean, yeah.
I find it really curious listening to the examples that are often given for a lot of these concepts where, yeah, mushrooms joined together, trees joined together, yeah, makes perfect sense, but that doesn't mean it explains all aspects of biology. And
I mean, yeah, that is very true. When it gets down to it, though, I mean, it's not even so much. I mean, biology is like kind of a springboard for this, even the larger view that these people take, which is that, you know, you think of like bits of your, you know, they like to use things about like electrons, for instance, you mentioned earlier, but like really those are just excitations, right, in an electromagnetic field, really. So like what you thought was a solid one thing is just a blip in a larger thing, and you think that field is unique too, but actually it's just interlaced with a bunch of other. And so like when you look at yourself as a persisting solid object, really what you're seeing, or what's really there is just a constant wave crash of activity. And so it's, I mean, the reason why he's going against this idea about...
That's not so wrong.
Well, no, I mean, there is something there, though. I think, I don't know, I mean, even though I have a paper against it, in general, I'm an essentialist, and I believe in substances, and I'm Aristotelian, so I think he's wrong fundamentally, but there is something there to say that, like, there is a kind of mesh or net of activity that happens. It's not as if things stay solid and constantly don't interact. I mean, it's...
Yeah, I mean, the problem with process ontology is not that the truth is that there are no processes, or that they're not important. The truth is that there are processes, but they're derivative from the underlying agents and substances and things that undergo those processes. That's, you know, it's not the, you know, deny processes. The usual thing with philosophy, there are two main occupational hazards of philosophy. One is skepticism, because it's so easy to be skeptical about anything you like. Just pick a subject and I'll reduce it to complete skepticism about it, you won't know anything. And the other occupational hazard is, you know, you take one thing and you fixate on that and think that's the explanation for everything. And, you know, processes, and, you know, processes are an important thing. You know, we can't get by without them. But then to say, well, they are the explainer of everything, gets you into a weird ontology.
Who was it who said that was essentially 20th century metaphysics? Just pick a category, ontological category at random, make that your fundamental category and just run with it.
Oh, I don't know. Sounds like...
It was meant to be a joke. It was meant to be sort of disparaging of metaphysics, but yeah, I can see it.
What did I say that?
No, I don't think
someone
someone said that. No,
it's the thing, you fixate on a particular thing and then that becomes the explainer. And, you know, it's a natural urge, right? Everyone wants to explain things by the, you know, the fundamental concepts that they work.
The problem I have when you say that, I mean, you know, I don't really have a darkness fight, I think is what you say. I mean, but whatever. But the problem I have is you go, no, there is entities and they have processes. And he goes, no, there's processes and they make entities. And I go like...
I don't think he even says that.
Well, he won't deny that you can sort of, that he's sort of there in some sense. I mean, it's just like a process that is a soliton wave, essentially, in all of this stuff. So, I mean, so all I'm trying to say is this kind of flip thing is something that you do in physics quite a bit for useful purposes. You go like, okay, this is too hard. I just flip my entire thing around, look at it from the other side. Oh no, suddenly things become easy. Flip back. And so you're very used to this kind of like, whatever, this, okay, that works, this, go back. And you just do this. And so that the problem is when I hear you, I go like, I don't know. I mean, how, unless you tell me what's the decider, what's the question that I can ask, that's what I'm trying to get at. What is the question that I can ask? And when that he will say, I don't have an answer to that, and you will say, I do have an answer to that. And if you have that question, then that seems to me like the thing. If you don't have that question, then I don't know. Then I don't know what to decide. I mean, and it's almost like a belief structure, right? I like yours more. It's more my style or something. That doesn't count for me in some sense, right? That's not a...
But you need to read all the details of his approach.
Yeah, that's totally agree. I've not read nothing.
There's a lot of stuff on genetics and you know, there's all different phenomena.
One of my issues with Dupré so far is that I'm not quite sure what the problem is that he's trying to solve with the process. I don't know why are you feeling the pressure to go this way? I don't feel this pressure. I don't.
Well,
if that's the answer. What's the question? Yeah.
I mean, yeah, I mean, I can't speak too much about it, but I mean, I think I'm not going to put it as pressure because I don't know what the pressure is, but I know his like targets, as you said earlier, is essentially kind of like Aristotelianism and substance-based views of entities. So it's, I think, you know, his study of biology and the interconnectedness of things, as it were, led him to think that solid things with definite boundaries are a kind of illusion. And because of that, and because of that, he thinks that's his fundamental ontological picture, is that what's important is not like the things that we choose to call stable, like these are the tigers and this is my hand. What's important is the flow of activity through which things go. So all of this metaphysics is meant to kind of like, the promiscuous realism, at least back in the day, was about more about species than anything else.
Yeah.
I mean, it wasn't necessarily about entities, but he took the promiscuity of species and brought it down to everything. And now it doesn't, you know.
I think the species problem is probably one of the pressures that has sort of pushed him in that direction.
I mean, yeah, if you were just reading his works exegetically and trying to get like behind his mind, I mean, that's exactly where you'd go. You'd think you're having problems drawing species boundaries. Well, now you
problems drawing every boundary.
That's exactly right. Exactly.
Yeah.
I find this really hard to understand, I have to say, because I mean, if you look at the complexity of, say, an organism, a tiger, okay, it might be very similar to another tiger, and it might look like a cat, and it might look similar to a dog as well. But if you actually look at the processes that go into the fate mapping of cells, so that they form in an organism in a particular place at a particular time, so you then go on to form fur that's a particular colour and legs in the right places and ears that are the right length in the right places. It's so complex to just explain it as just like a sort of stuff happening, a flow of stuff happening, just seems ludicrous. Sorry.
I'll send you my paper because that's
Yeah.
exactly right.
I don't send your paper to.
Yeah, I mean that's exactly. I think that's
really
exactly right. Again, I'm not going to rehearse it here, but the point of the paper is sort of, the punchline in a bit is that you can't have just processes. There are no such things as just a going on. If there's a going on, it's a going toward or for something. There are specialized systems that produce specialized things.
And also, why does it keep happening? So
exactly,
the reason why all
regularity.
tigers look similar and the stripes are in the same place is because the process is been rehearsed lots of times. It works.
Right. I mean, at any rate, yeah. I mean, there's a lot to say about process ontology, but it's an interesting angle, Stephen.
To be fair to him, he thinks it's these stability bits that need explaining. So he would accept that that's a question. Why do we repeatedly get tigers? Well, that's the interesting thing that biology has to explain. Everything is flowing, everything's kind of mushy, but we get certain kinds of things.
Tigers are not very mushy if they come in.
It comes down to some of the fundamentals of like the origins of species and why some disappear and possibly the reason why you keep getting tigers is because they're designed to breed, and that means you get more tigers, and they go through the same. And at some point, if that process stops because of climate change or something like that, I don't know. Maybe I need to read the paper, then I'll understand it more.
Well, have a look. Just read the manifesto.
Yeah.
If you've got time, right? Because it's not your fight. You don't need to worry.
It's not part of a mistakes project. That'd be a 10-year project.
Now, so for me, what I'm after is a kind of moderate reductionism, moderate anti-reductionism, something that's going to do justice to the biology as far as we think we know it, but not go the whole hog, bringing political ideology into the study of the natural world, or giving up on the idea that there's order to be found in the natural world that's mind independent. And we'll stick with it. I want the mind independent stuff. So that's what I've got down here at the bottom. One metaphysical framework which provides a kind of the sciences and their interrelations, preserve systematic order in the natural world while recognizing that ontological reduction of one level to more fundamental levels is unlikely. I think it's worth trying for it, so I don't think there's anything necessarily wrong with methodological reductionism. Give it a go, but don't expect it's going to happen. Try it out and see, but it shouldn't be, and it probably isn't, dogmatic with the basic, the people who are in it for the methodology. So it's unlikely. It's not going to happen all that often. And the caloric example is the one example of a clear reduction that I'm aware of.
Well, nuclear forces.
This is.
Well, I mean, it's not been done perfectly, but it's pretty clear that one comes from the other. I mean, we are reasonably certain. I mean, it's not just out of we think, we dream of it, but it's very clear that that's happening. So there's more. I can say many things if you want. Actually, look at cells, look at crystal structures, and falls on that. Talk about material properties, right? So you can reduce why can you hammer out gold? Why can you not hammer out other substances? You can look at the crystal structures and you know exactly what's happening. You see the fault lines slipping. You can literally think about what's happening on the atomic level. You can do superconductivity and there's a lot of things where you go like, I see something here, and I go down and I see something there. So.
I think I'm probably bringing in this whole idea of eliminating entities when you go down, as in the caloric case, where we just sort of eliminated that.
Well, it is always a little bit like that, right? I mean, if I explain the malleability of gold in terms of slips of I mean, these are different words, that's what I'm trying to say. They're not the same thing. I mean, you might say, okay, well, one leads to the other, but that's always the case, right? That's also the case in the statistical mechanics explanation of thermodynamics. You explain one with the other, that is reductionism. But they're not you're not saying the same words. Pressure is not, malleability is not the cracks. It's the cracks explain slipping, is what explains the malleability, but they're not, you're not saying the same concepts, right? We don't have malleability at the crystal level.
So there's probably more than one or two examples, but I'm not going to, I don't think it's going to be the...
No, I totally agree. No way.
Okay, so this is when I say, okay, but look, I'm just going to put the thesis on the table. This is where I think is going to thread the needle for me, make sure I've got enough reality, enough of a ordered world that we can study and hope that there's going to be systematic relations between the various sciences, while still recognizing the level of anti-reduction that we've been talking about. And so these are a bunch of claims. See what you make of these. Reality is ontologically layered. We've already talked a bit about what that might mean. For me, it's constituent parts. If you want to talk about layered cakes, metaphorically, fine, but as long as we make sure we aren't being metaphorical, then we're going to do that. 2 is optional, but I think I'm willing to stick my neck out with this one and say that there is ultimately going to be a fundamental or basic level. So it's not going to be an infinite number of levels. You want a case for that, and have to bring in notions of the infinite and whether reality can be vague and all that. But that's not the most important claim. 3, every other ontological level is ontologically dependent on the levels below it, in a relatively routine sense that if I don't have the parts of the whole, I can't have the whole. But I would also be willing to say things like accidental properties like color will depend on the fur. This particular instance of this fur color depends on the hair being there. So there are ontological dependency relations of various sorts. This is where I depart from what I take to be classic reductionism. That is that each ontological level is equally real. Now, I kind of fudged this when talking about the classic form of this, but the third bit was the hierarchy, where they said each level, more fundamental levels, were more explanatorily important. I put it that way because I thought that was less contentious, but a lot of them will say, the further down you go, the more real you are. And I don't want to go that way.
What do you mean by real?
Yeah.
I think.
Well, yeah. There are degrees of reality. That's an old metaphysical idea, goes back to Plato. I don't want to go there. There are some...
Why is real in scare quotes?
Just because I don't want to have to say what real is just yet. I mean, it'll become clear. Why do I do that?
It's a classic David Stoke point, about how he always. I'm having a bit of a joke, but I mean, David Stoke always used to say that.
I'm not, backing away from real. I mean real. I need to tell you what I mean by that, but I do mean mind independent. It's out there. If we die, it's there. That kind of thing.
What about fundamental? I would want to put quotes around that. or at least spell out what we mean by it.
Yeah, for me, it's there in three. It's something is fundamental to something else, the other is ontologically dependent on it.
Oh, okay.
Yeah,
It's
so
not an
if
intrinsic
that's-
quality, it's a relational.
Yeah.
Yeah.
Now, the reason I go for each level is equally real is it's actually a point that I think Dupre would be happy with, but which comes from the scholastic tradition. And levels of being real is always keyed to activity, to actually doing something. There's no being a real thing without having some kind of impact on other things which are real. That's part of what it is to be a real thing. So, yeah, that's the gloss on real. Right, so if I'm given something which is allegedly real but has absolutely no causal connections with anything else, I'm not sure that it's real. So I'm not particularly fond of abstract objects. If abstract objects are supposed to be things which exist outside of space and time.
I totally agree, except you actually reverse the dictum, right? The dictum, as you quote, it says action follows being. You're saying being follows action. If I detect an action, I can determine that there's a real
Well,
being.
Epistemologically, action comes first, but ontologically, being comes first. That's where I separate from Dupre. Dupre seems to think, I mean, if I was being kind with him, I think he was doing what you're doing. He would know about the action, stick with the action. That's where things are epistemologically more accessible. And then, okay, well, maybe forget about being. I think that's ultimately what he's doing. Don't bring it in. I just can't get my head around that. And I think it's the other way around. Do what a classic scholastic would do. Stick with being first, action comes second. But the way you come to find out about the being is by investigating the action.
It seems perfectly
What's it
reasonable,
doing?
yeah.
That's how you know when a thing is.
Whose classicism is very reasonable.
Yeah, I mean, it's worth noting that like other process ontologists, in particular like Nicholson, who's also in that thing, and like going back further, like Rescher, specifically cite this dictum and cite how it's wrong, right, or the thing that it's backwards. Yeah.
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 I find myself using action follows being a lot. I find it just organizes so
it helps with so much, doesn't it? Yeah.
I'm not even sure that, I'm not sure you're quite truthful. If you say there's no being without an action, I think that's more than an epistemological claim.
It's a metaphysical claim.
Yeah.
It's a metaphysical claim, absolutely.
Yeah, and then you're saying a being is in some sense defined by the fact that it
Let you do something.
Yeah. In that sense, I'm thinking you're reversing.
No, this is how I would distinguish between a real thing and an abstract object, or a fictitious entity, or a hypothesized entity that I'm thinking might be there but ends up not being there. Like, how would I be able to say, no, this thing doesn't? Well, I haven't found it doing anything. I've got nothing down here that I can point to. Says, see, there it is. There's the effects of so and so.
Well, is this a living being?
Anything, absolutely anything. Yeah.
Yeah, but you're not saying I have no evidence of this being. They're saying I require kind of like, if you want to be a being, show me your action, right? And that is a little bit more than saying, I just didn't see anything, so for the time being, I don't know that this thing exists. That is epistemology. That's me looking at the world, detecting things.
The reason why this dictum is useful is that it's stating something metaphysical, but it's giving you an epistemological.
Yeah, sure. I totally agree with that epistemology form.
So if you want to find out what the being an entity is like, look at what it does. And then once you see what it does, you can start to infer, well, it must have certain kinds of powers, it must have a certain kind of nature.
Anyway.
Yeah. And so I'm thinking at each level, there is a set of activities that are not at lower levels. That's what makes the next level up real. And if real is being active, then you're as real as anything else that's So I don't need to say that one level is more real than another. I'm gonna find that hard to get my head around anyway, but I also think it leads to reductive style thinking. You wanna go where the action is, it's down low. Well, no, I mean, the action is everywhere, it's at all the levels, and yeah. Don't be tempted.
It's 2. Why do you want to hang on to 2? I used to believe 2. I just don't think I'm not sure I believe it anymore. I'm certainly more sceptical about 2 than I used to be.
Schaeffer's paper. Did you see Jonathan Schaeffer's paper on whether there's a fundamental level or not?
Yeah, I read it.
Yeah.
He's written about 10 of them, hasn't he?
No, it's
Sorry, say that?
So he's written about 10 of them on.
I was just going to say he's written a lot of stuff on. But is there a fundamental level? I think is the one. Yeah.
Uh-huh.
What I thought was interesting about the paper was that everybody seems to be assuming that there's this ontologically fundamental level, but the arguments are crap for it. Yeah, actually, you're right. The arguments for it are pretty poor. The best arguments I can see are actually the old scholastic arguments. I think they're actually interesting when seen as being an argument, particularly the first 3.
Have you written something on this?
No, I haven't. Actually, I have. Have I? Yes, I did. I think it came out in my last book. You know, I think I said something about it.
I mean, give me an argument. You know, give me an argument that I'm likely to kind of accept the premises of, if you know what I mean.
The whole infinite regress thing. You know, why on earth is an infinite regress impossible?
Yeah.
And I've always thought that the main reason for that is because the basic Aristotelian point is that for anything to be real, it has to be definite. Circumscribed, definite, and the whole thing about an infinite thing or an infinite series is it doesn't have that definiteness to it.
About cardinality.
Why you can't have the infinite series, because reality would have to be, and that's why can you have vague objects? That interesting paper by Gareth Evans comes back.
Can I pick
What
you up?
about alephs and cardinalities of infinity?
Say that again?
Like alephs, if you is it alephs or alephs?
Aleph, yeah.
Aleph?
I don't know.
Like if you have, you can compare, you can compare different sets of infinities, as it were.
Unfortunately, I do have to bring in. I'm not a realist about mathematics and sets, so.
Yeah.
Yeah.
Can I pick you up on another point? You're saying, I think 3 and 4 are kind of contradictory, or at least fight with each other, because you're saying in 4, all levels are equally real, equal, right? And then you're saying in 3, but some are dependent on others.
Yeah.
That's not equal.
Well,
If I depend, if something is depending on me, it's not my equal.
Well, not in some sense, but your liver is as real as you.
Yes.
That's all that means.
Okay, fair enough.
Yeah. Now, and this is where.
Well, yes. Yes and no. I mean, it's not really true. It's not. It is. Like you take the liver out of me. In some sense, it kind of.
Well, you're dependent on each other.
It will be bad for me.
That comes later. I mean,
Okay.
I think there is a difference between livers, body parts and full bodies, and it's going to come out in terms of actions and processes, and whether you can continue doing what you do in certain circumstances, and that'll be a way of distinguishing between parts of wholes and aggregates and all of that kind of stuff. But the world contains livers. I think that's,
Yeah, that's fair enough.
yeah.
Stephen, just checking on time now.
Oh, yeah.
You've got more to say. If we're going to get there for 5, we need to go in 10 minutes, but we can go on talking.
So maybe you just finish the talk.
We're pretty much there. We're pretty much there. Where do you get new being, new action? Well, I'm quite happy to go with this new part-whole arrangements that can come along. You can. We haven't always had the parts of wholes living together. I mean, this is one of the classic moves in the early phases of moving to multicellular life. Something that was on its own starts to live in something else, and then, okay, well that's a model for how you can start getting from the lower levels, metaphorically, simpler levels to higher levels by putting them into new part-whole arrangements, and then they come emergent properties, and then interactions with other things, new part-whole arrangements, the same ontological levels, and appealed here to the stages of life on this planet. That's the way you get new stuff happening. More complexity, more properties emerging out of relations that weren't there before, you move on.